Now, hopefully this video will be on the right screen. This is Euler's method. We're trying to find y values from a dy dx equal to some function. We're trying to find what the y value would be. So we're going to borrow something from the past, the definition of derivative, where f of x plus h is going to be the next y value, and this is the previous y value, and over h, and we're just going to designate them as terms, like y of n plus 1 is the next y term. Y of n is the previous y term. So this essentially is the next y minus the previous y over h. Yeah. H is whatever you want it to be. And you'll do better if h is small, but it's more work for you, as we'll see. Yep. Now, this derivative, this thing here, this is the formula that we're going to compare it to. And so if you do some algebra here, if you take h times f prime, and they even take this prime out sometimes, they'll just call it f. So you don't even need this little prime thing here. This doesn't even need to be here. If you take h times this and then add the yn, you're going to get the next term. And so this is Euler's method, Euler's formula for finding it. Now the sad thing is you have to do this many, many, many times. Sometimes 20, 30 times. So what would we do if we had to do it 20, 30 times? What would we use? A computer, right? We wouldn't do it ourselves. But on a test, you'll do it maybe 4 or 5 times. So the question is, how do you actually do that? Well, this is the formula, y of n plus 1, y of n, and it's called a recurrence formula because you use the answer to get you the next one, Okay? H is what we'll call the step size. We start at h0 and we get to x, as you're going to see. And once you see one of these problems worked out, it's pretty straightforward. I'm going to show you a lot of steps, and I want you to write them all in the first time. And whatever you want to do to shortcut it, as long as you don't make mistakes. If we see these on a HL exam, we jump up and cheer hooray, because you can't make these difficult. They are what they are. You just do the same thing every time. It's just a lot of picky stuff. So this is my formula for f of x comma y. Excuse me. Okay, we're going to get started. We're going to do the first step. We're going to start out at x0 equal to 2, y0 equal to 5. And we're going to creep 0.2. Excuse me. And you're looking for y1. That's what we're trying to do. So y1 is equal to y0 plus h times 3 times x0 minus 2y0 plus 1. Now I'm writing this out because it'll help to just substitute in next. So we're trying to find y1. y0 is 5. H is 0.2. 3 times 2 minus 2 times 5 plus 1. Help me out. I always make arithmetic errors here. I'd love not to make some today. 6, 7 minus 10, is that negative 3? Does that sound right? So we'll get, what's that? And then 5 minus 0.6 will be 4.4. All right, so then I like to shrink these a bit. There's the first step. Now we're going to do the second step. Now we have x1, we have y1, we still have h, we're looking for y2. And x1 is going to be one step, so we're starting at x is equal to 2, we're going 2.2, then we're going to go 2.4, we're trying to get to 2.6. We, the first time, went to here. Now, and this is 0.2, that's what our h is, right? Now we're going to go to the next step. H is still 0.2, so what is my new x? This was x0, this is going to be x1, which is what? 2.2. And then y1 is going to be 4.4, which we had before. H is still 0.2, and we don't know what y2 is. That's what we're trying to find. Then we go y2 equals y1 plus h times 3x1 minus 2y1 plus 1. And we plug in. y2 is equal to 4.4 this time, plus 0.2, 3 times 2.2. Now you're going to need your calculator. 2 times 4.4 plus 1. And could somebody calculate for me what that total is? All right, so 4.16. Great. So we did the second one. I'm going to shrink that too. You see what I mean? This isn't hard. Is it a little annoying though? Yeah. It's very annoying. So we're going to do x2 equal to 2 point what this time? 2.4, because we're going to go to the next one. H is equal to 0.2. But look at where we're going to end up. When we go to 2.4, when we do this one, do we need to do another one? No, because we're going to land on 2.6. So the tricky part of this is, even though we're going to 2.6, you don't do the 2.6. You do the one before and stop. That's I think the only real tricky part. So you have 4.16. H is still 0.2. Y3 is going to be, don't know. So then we go ahead and put the y3 equals y2 plus h times 3x2 minus 2y2 plus 1. And y3 equals 4.16 plus 0.2, 3 times 2.4, 2 times 4.16 plus 1. And I'm going to need your calculator help again. $4.136. Anybody second that? Yes, good. So f of 2.6 is estimated to be 4.136 using Euler's method. Is it perfect? No. Is it an estimate? Yes. But this is a way, if we didn't know how to integrate this, which we don't right now, then we can still find that y value if we're relatively close. Yes?
Should we add 3 zeros on the end of that? Because it says 6 decimals when it for the answer.
Oh, did you guys round these?
No. But what should we do if it's not?
Oh, I wonder why it says 6 decimals. Oh, I know why. Is because I used to do this one like to, I think it was to 3.
Oh, okay.
Yeah, so this, sure, we could put 3 more on there. Yes?
So is this formula that we use going to be same across all these kinds of problems? Or
Every
is it
one.
specific to this one?
Every single one. They never change.
Even like the 3x.
Oh, no, that's this
Oh,
particular problem. But,
the format of it's going to be.
yeah, so y of n plus 1 equals y of n plus h times f of x of n, y of n. That's always the same.
Okay.
Yeah, isn't that nice? So this is kind of a little island of niceness. Is that the only thing that isn't nice is that you got to do, it's tedious, right? So here's what your assignment's going to be. Your assignment is going to be to do these problems using Euler's method. And I usually try to make them reasonable so they're not, like 10 or 20. I think this one has quite a few, though. It says, using step sizes of 0.5, use Euler's method to approximate the value of y when x is 3. So we're going to start here. dy dx equals 3x squared. If you want to, just call this f x of n, y of n. That's what that one is. We're going to start with x0 equal to what is the very first x. You're going to get it from here. It's either 1 or 2. Which one is the x? 1, yep. Yep, and then what's y0? 2. Yep. And we're going to go in increments of 0.5. By the way, it used to be 0.1. I changed that. And then this is going to be y1 is what we're going to be looking for. Just to start you out, so we're going to have y of 1 will be y of 0 plus h times, well, here's the formula, x of n, y of n, 3x squared. So it's just going to be 3x0, in this case, squared. And then you just go ahead and plug in. See what you get here. .5 times 3, which is 3.5. Yep. Okay, then you go ahead and do the next one. x1, y1, h, and y2. What's x0 going to be this time? Or x1, I mean, 1.5, and then it's going to be 3.5 for y1, and we're still doing 0.5. And I'll let you finish with Euler's method.